The last topic that we're going to address here as we talk about graphs is how sometimes people will be misleading with graphs. And advertisers, we talked a little bit about how, part of the purpose of this class is to be able to kind of detect when people are saying things that aren't necessarily true, and to have a little bit more of a critical eye. And so you can see here we've got these two graphs that look like two totally different graphs. If somebody presented you with this graph on the right, you would look at that and go, wow, in 2006 there were so few people going to Denver International Airport. For whatever reason, I wonder what that is. But if you look more carefully, what you'll notice is that these two graphs are in fact the exact same graph. Well, at least the exact same data represented, but the graph on the right represents that data in a very misleading way. And you can see that by looking at the vertical axis here. Notice the graph on the left, 2006, right around 47 million passengers. Graph on the right, 2006, right around 47 million passengers. It's actually the exact same data, just presented in a misleading way. Now, we talked about how when you make a graph, sometimes you might not want to represent everything from 0 million to 2,000 or up to 55 million, because in this case, at 0 million, there's not anything going on. In fact, the graph doesn't even start until after 55 million. But another thing that we did talk about is if I'm going to do something like this, I should really put the truncation marks here to show that I'm jumping past a lot of information. And I would say even, extend the graph upwards a little bit and have my 47 start there, put my truncation marks in and make it very clear that my data is, that I'm kind of jumping purposefully over some data. Notice, even if I do label it clearly, the relative differences between these bars is still vastly different. And so we have to be careful when we make these kinds of decisions about what we're saying with our graphs. So it's important that we're very deliberate about what we do when we make these graphs, and that we're very clear if we're going to make any kind of leaps from 0 to 47 million, that's what we're doing. It is labeled on the axis here, but really we should at least include some truncation marks to show, hey, look, we're skipping over a whole lot. Another way that we can make graphs misleading, or we can find graphs that are misleading, is what people will sometimes do is, instead of drawing just a bar graph, people will sometimes draw these boxes to represent areas. And the problem with this is that if you look at this, and this is something that Steve Toner had pulled off the Daily Press a few years ago. If you look at this graph and you look way back to the 1950s, I mean, number one, I can't even read, but let's even just look back here to where we can kind of see, it looks like it was 5 cents. Let's look over here in this part of the graph. Or even, let's just compare these two parts, the 39 cents here in 2009, up to 2009. And if I compare that to this giant $1, 1 cent, I'll tell you the vertical heights are to scale. Yeah, that's fine, that's good. This is 39 cents, this looks to scale to me. The problem is, how many of these little 39 cent rectangles can I fit into this figure that they've given me? It looks to me like I can fit 6 of those potentially, kind of breaking it up, which might suggest that taxes are 6 times as much to somebody. They might look at that box and think that it's kind of more exaggerated than it is. Where if you go ahead and just read what it has to say here, it even specifies that it's twofold, that the increase is just up a little bit more than twice as much. But the box here is misleading because it's so much bigger than the 39 cent box right next to it. And so you have to be careful when you're doing something like that, not to exaggerate the amount of increase from kind of one quantity to the next. Now, this one is one of my favorites in terms of, misleading graphs. Not that I'm happy about misleading graphs, but because this is something that would be just so easy to do. Even as a student, as you make a graph in Excel or something like that, and you have this 3D graph, and the 3D graph really looks nice, but the problem is with perspective. In fact, if you look at these two graphs, they represent the exact same information. Now, if you look at the numbers, that doesn't look like it's the case. Look at male senators. It looks like it's somewhere around 70, 72. Female senators looks like it's somewhere around maybe even 15 in that top graph. But what I want you to pay attention to is that if you look right underneath the exact same chart, it's very clear to read that the number of male senators is 80 and the number of female senators is 20 at the time that this kind of information was gathered. So why is it that this graph on top looks so different? Well, if you look at it, to make it appear 3D, it's almost as if we were looking head on at that graph on the bottom, and then started to kind of go up, so we'd be able to see the top of the bar. Okay, so imagine if we're kind of looking at this just head on right here, and then we start to go up, and then as we go up, maybe we realize that this bar is actually a 3D bar. But to notice that, we had to move up, and we had to move to the right a little bit from where we were looking at it. And in that perspective, when we move up and we move to the right, it changes. Also kind of in the background, we've got this bar at 80, and it would change just because of where we moved, because of the parallax, if that makes sense to you, kind of like the weeds that are closer when you're driving. You can't say trees in the high desert, right? We have to use weeds. The weeds that are closer when you're driving are going to move faster, and if you look farther out, the weeds that are farther out look like they're moving slower relative to the car. So that kind of same issue, we'll call that parallax, makes these bars look like they're in a different position than they actually are relative to the background. And so even though I see students see this and they think the 3D graphs, if I have somebody do an assignment, they'll throw those 3D graphs in a non-stats class a lot of the times because they think it looks nicer. But in reality, it can be misleading, and you need to be careful about that. So those are just a couple of different ways that you need to kind of be watchful for on your own or when you're watching TV even, because sometimes people will do that on accident and be misleading and not really realize it, not pay close attention and realize, hey, these graphs look like, it looks like there's only 72 male senators and there's only 15 female senators, when in fact it's 80 and 20. But companies are purposefully misleading in advertisements all of the time. And so they might use something like that. This is a tool to exaggerate, especially in that first graph that we looked at, to exaggerate the differences when the differences maybe are in the end more subtle than they look. So beware of those misleading graphs.